In this video, we will be looking at a few revision tips for your upcoming test on proportionality. The sort of things we're going to be covering are calculating the fourth proportional, looking at a situation of proportionality, solving speed problems, using percentages, and also a quick look at distance time graphs as well. So the first one here is calculating the fourth proportional with a method of your choice. Often you'll be presented with questions that will have the proportionality grid. You should be familiar with this by now. There may be labels, it may just be numbers. This one I'm going to show you here is purely numbers, where you have two relationships here and they are proportional, and they want you to find the missing number. So the way we look at it is we look for our missing variable, missing number here, which is x. And what you do here is the two values that are directly opposite each other like that. We multiply, so it's 17 times 3, and then you divide by the other number, which is the one opposite x, which in this case is 6. So it's 17 times 3 divided by 6. Put that into your calculator and you get an answer of 8.5, and 8.5 then would be the answer, would be the number that would go here. So remember, it's these two multiplied together divided by that one. Give you another example. I'll give you another grid here. Let's just put some numbers in. And this time we're going to have, let's put our unknown up here. So y and 2 and 22 and 5. Doesn't matter what these values are in this case, you're just given the grid. And if you're given the grid, just use the grid. It makes life a lot easier. So we're looking for y. So y will equal these two numbers that are diagonally opposite, multiplied. So 22 times by 2, divided by the other number, which here is 5. So 22 times 2 divided by 5, and that's going to equal 8.8. Now you might be given the question involving words, and that gives you the freedom to present a solution however you choose. So let's look. It says it takes Dave 30 minutes to read 12 pages of his favourite book. So that's 30 minutes, 12 pages. And the book has 600 pages. Assuming he reads at a constant rate, how long will it take for Dave to read his book? So I'm just going to use the grid again because I think it's by far the simplest method to actually use. So what I want to do here, I've got 30 minutes, 12 pages. So I'm going to go for minutes and pages this way round. I'll label it so I know exactly what I'm putting in. So I've got 30 minutes, 12 pages. Now, the book has 600 pages, so my 600 goes into this box. And my unknown I'm going to call t because it's the time, and that's what I want to know how long it will take. That's the time. Goes into the space there. So to find t, what do? I multiply the two numbers that I have that are diagonally opposite. So in this case, it's going to be 30 times 600. And we divide by the other number there, which is 12. Put that into a calculator, you will get 1,500, and the units here is minutes. We wouldn't normally leave it like that. We would say, well, 1,500 minutes is equal to 1,500 divided by 60, because it's 60 minutes in an hour. And that gives us the answer of 25 hours. So put a sentence, say Dave takes 25 hours to read his book. Hopefully not all in one go. Just looking at the question again, there may be an additional part to this question. So they might ask how many pages he reads per minute, for example. So if we wanted to work that out, pages per minute, that would be called the unit rate. So what we do there is we just take one pair of numbers that we know. So we know it's he takes 12 for 12 pages. He takes 30 minutes. So if it's pages per minute, per means divide. So that's going to be 12 divided by 30, which is then an answer of 0.4. So it's 0.4 pages per minute. And again, we could put a sentence on that saying Dave takes an average of 0.4 or reads an average of 0.4 pages per minute to read his book. Okay, question 2, it says know a situation of proportionality. I want to give you a couple of examples, and I'm going to subject you to some pretty terrible drawing. Let's say that someone has a car. So let me draw a car. We're going to make this an open top car, I think. So we've got a little front bit there like that. Okay, there's my supercar. And they also have a toy version of exactly the same car. So let's make this pen a little bit thinner. So we've got a smaller version of the car, toy version of the car. So maybe the mum and dad drive the big car and the children drive the smaller car. But one is a smaller version of the other. And let's say with these cars, the big car is 6 meters long and is 1.5 meters high. Let's make that look a bit more like a 1.5 meters high. And then we look at the small car, and the small car, the toy one, is only 0.5 meters, so half a meter tall, and is 1.2 meters long. So, and we want to know, are these proportional? Is one proportional to the other? Well, if they were proportional, then we could put the numbers into proportionality grid, and the answers would work out. So let's just try this out. I'm going to do a little proportionality grid and just put in my pairs of values. I have 1.5 meters height, 6 meters length on the big car, and then the small car is 0.5 meters and 1.2 meters. Now, is this true? Does this follow the rules of proportionality? Because if it is, this value down here, for example, would be made up of these two numbers multiplied together divided by this one. So is 1.2 equal to that? Well, let's try. We do 6 times 0.5 divided by 1.5, like that. And if I put that into a calculator, I get the answer of 2 meters, which does not equal 1.2 meters. So they are not proportional. Let me just recap that, because that's a difficult concept. I've got my two vehicles. If they were proportional, then I could put them into proportionality grid, and this number here would be equal to these two multiplied and then divided by that. So we try that. We multiply these two together. We divide by this one. If we get 1.2, they're proportional. In this case, we don't. We get 2 meters, so they are not proportional. Another way you could do it, for the same question, you could just do, let's do 1.5 divided by 6. That equals 0.25. And then I could do 0.5 divided by 1.2, and that equals 0.416. These two numbers are not the same. They are not equal. So, not proportional. Let's look at a similar situation. Let's go for two models of the Burj Khalifa. So it's going to look something like this, just in outline. It's pretty terrible drawing, really, but you get the idea. And then we have a smaller version. Please excuse my drawing. And let's say that the large model is 100 centimeters tall. So that's 1 meter tall and 20 centimeters wide. And the small one is 25 centimeters tall and 5 centimeters wide. Are these proportional? So, I could put them into the grid again, like I showed you on the previous example. So I would have 100 over 20. I would have 25 over 5. And if this was true, then this number here would be equal to these two multiplied divided by this one. So let's try that out. Let's do 20 multiplied by 25 divided by 100. Put that into a calculator, and I get the answer of 5, which is the number that I was looking for. So yes, they are proportional. If you don't like that method, you could just look at what's the relationship between the height and the width on both of them. So we could do 100 divided by 20, which equals to 5. And we could do 25 over 5, which equals to 5. These two numbers then are the same. So yes, it is proportional. The small one and the big one are proportional to each other. Next up, we have solving average speed problems. So let me give you a scenario where there are two towns. We will say town A and town B. And these two towns are 163.5 kilometers away from each other. And if we say that Adam drives his car, hopefully it's better than the one you saw the picture of just now, and say it takes him 2.5 hours to complete the journey. What is his average speed? Well, the first thing for any question like this, you need to write down the formula. Speed equals distance divided by time. We know the distance and we know the time, so we can put them straight into the formula. So we have 163.5 divided by 2.5, and you put that into a calculator and you get 65.4 kilometers per hour. Always, always, always put the formula first, then substitute, put your answer, and then you would write a sentence saying Adam has an average speed of 65.4 kilometers per hour. So put the sentence in there as well. Now let's say that somebody else, let's say his friend Sophia, she cycles the same distance. It's a long distance to go on a bicycle. And that is at an average speed of, let's say, 21 kilometers per hour. That's a decent speed for a long distance ride. And we want to know how long does it take. So how long? What's the time? So what do we have here? Let's do this in blue now. So we have the speed and we have the distance. So let's just put our formula. Speed equals distance over time. Speed is 21. Distance is 163.5. And the time is what we're trying to find. Now our unknown is at the bottom of the fraction here, so we can bring that up here and bring that down there. We can basically swap these two. So I create a new formula to say the time is equal to 163.5 divided by 21. Put that into a calculator and I get 7.8 hours for the distance, for the time taken for that trip. Again, write a sentence to say Sophia takes 7.8 hours to travel the distance from A to B. Now we've seen how to work out speed, we've seen how to work out time, so it seems only fair to do a question involving distance. So let's take Adam again with his car, and let's say that he now travels from B to C. And we don't know the distance this time, but we know he travels at 72 kilometers per hour this time, so he's gone slightly faster than before, and he's going for it takes him 3 hours to get to C. And we want to find the distance. So find the distance. So our formula, speed equals distance divided by time. Our speed is 72. Our distance is D, we don't know, and our time is 3. This time our unknown is at the top of the fraction, so I need to multiply both sides by 3. So in effect, I've got 72 multiplied by 3 is equal to D. And if I multiply 72 by 3, I will get 216 kilometers for the distance. So I then write a sentence to say that Adam takes, the distance from B to C is 216 kilometers. Remember, for each of these questions, formula, substitute in the numbers, solve the question, put the right units, and then write a sentence then as your answer.